Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, we'll be talking about R building blocks, including using R as a calculator, vectors, assigning variables, basic built-in functions, subsets, Boolean, comparison, and missing values. In the second part of this video, we'll start plotting using ggplot, an implementation of the grammar of graphics. Here we are at the course website. I'm going to scroll on down to the timetable, and we are here in the third week, R programming. So you'll find the videos here. Not only is the notes for this at chapter 00, yes, I start my chapters at 0, but at this R link is all the R code in this chapter. So I'm going to open the R code in a new tab. And here it is. This is the code that we'll be looking at in a moment inside of RStudio. So let me go over to the notes. Here's our introduction, and here's where we're going to get started. Now I'm going to actually interact with R throughout this presentation to show you what it looks and feels like. You have to use your imagination for that part, or put your hands on your own keyboard and feel the interaction with R. So, R is a calculator. Let me go over to RStudio. Here we are. I'm going to press Control L to clear the console, and I have already opened this file. Here it is. Okay, and I have started each section of the notes with 4 pound signs. Okay, I refuse to call them hashtags. So those are pound signs. And that's where we're going to be. Alright, so R works perfectly well as a calculator. Okay, so if I'm down here in the console, I can press 2 times 10 and press enter and expect an answer of 20. I'm going to do a lot of this interaction by having my command prompt in the upper window. That's the editor window. And notice that there's a command here, run. Okay, so if you click that button, watch the console down below. It's going to take this line and it's going to copy it down to the console and then submit it. Okay, whatever the current line is. So I'll press run, and it submitted that line, and it incremented up top down 1 line. So the next one is 1 plus 2. I'll press run, and it will send it down. Now, that's the last time I'm going to click that button. Notice when I hover, it says Control Enter to run the selection. That's what I'm going to do from now on. So if I press Control Enter right here, notice I've got a line that starts with a pound sign. That is a comment. That is a line that will not be interpreted by R, but instead is there for us, humans, to read and understand what is happening in our code. So I'm going to press Control Enter right there. It will submit that comment line to the console, do nothing, and increment to the next line. R knows about orders of operation. So in this line we've got 5 times 10, which is 50, plus 1 should give us 51. If you put 1 plus 5 in parentheses, add those together first, you get 6 times 10 is 60. That's right. Alright, if you want to do exponentiation, the Shift 6 key on a standard QWERTY US keyboard will give you the caret, that little up triangle, and 2 to the 5th power is 32. 9 to the half power is a square root. That's equal to 3. Alright, we know our math, and so does R. So that's the first section. One thing you'll notice is all these bracket 1s at the beginning of each line. I'm going to tell you what that is shortly. There is a function in R, starts with the letter C, and ends with that same letter because it's 1 letter long. It stands for combine. We can look up help for any of these functions. So down below I'm going to do a question mark C, and I'm going to press enter here, and in the help window on the top right for me, the letter C is a function that, and the description here is, oops, sorry about that, is to combine values into a vector or list. So that means if I see with parentheses and have a list of items separated by commas, that will create a list of 4 elements, 1, 4, 6, and 7. Okay, so that's a list that is 4 elements long. In fact, just for the heck of it, I'll add a line here. Length, what is the length of this combined, this list of things? That is a length of 4. Okay. The next one, 1 to 5, that's going to give us the sequence 1 to 5. And if I combine that with the number 10, press Control Enter, there's my list. Alright, so combine is a very handy function. There's other ways of generating regular sequences of functions, or of numbers, my apologies, and that is with SEQ, that is the sequence function. So this sequence will start at 1, it will end at the number 10, and it will go by 2. So this is the moment where we're going to start thinking like the computer. For every statement that we run, we should first be able to visualize that line in our own minds to understand what the computer's about to do, and then ask the computer to do it and verify whether our intuition matched what the computer understood. Okay? The closer we can think about operations like the computer can, the better programmers we will be. So, what does it mean to go from the number 1 up to the number 10 by 2's? That means I'm going to start at 1, and then I'm going to go by 2's. So it's 1, 3, 5, 7, 9, and then I hit 10. 10 is not in the sequence because it's not by 2's from 1, right? We ended at 9. So let me run that line, and that's what happened. Okay. How about this? Here's another way to run sequence, and of course for each of these commands you can always ask for help by doing $SEQ for the function name. Press enter, and I'll make the help window a little bit larger over here. Here's the function definition with the arguments from 1 to 1. So you're going to plug in your values there like I did 1 to 10 over here on the left. And then there's 2 possible arguments. One is to say by, as we just did. We did by 2's. And the other one is to ask for a length. Okay, and this length is what I'm about to specify. It says I want a sequence of numbers that starts at 0, ends at 50, and is 11 elements long. So you have to sort of work backwards in your mind, but it turns out that if you start at 0 and go by 5's, 0, 5, 10, 15, 20, and so on, that will give you a list of 11 items. Okay. Notice that if I start at 1 instead of 0, I don't get those nice multiples of 5. There they are. All right. There is shorthand, as we've seen. 1:10 will give us the numbers 1 to 10 by 1. Okay, and that's the same as specifying the sequence of 1 to 10. R knows how to count backwards too. If you ask from 5 to 1, it indeed will count down 5 to 1. All right. So there's no reason to go by integers or nice rational numbers. It takes irrational numbers as well. Just a secret here. A computer doesn't know what an irrational number is. All right. So this is going to go from 0 up to 100 times pi by pi. How many elements will be in this list? If you said 100, you are 1 short. There are 101 numbers in this list. And so now is the time when I can tell you a little bit more about those numbers in brackets on the left of the output. And I just want to scroll up a little bit more to the beginning of this list. All right, so it starts at 0. Here's pi, 3.14. There's 2 pi, and so on, until you've got 100 pi's. Sort of the opposite of 100 beers on the wall. All right. So these leading numbers in brackets is the index of the list that is printed. So the 1 here indicates that this first number on this row is the first item in that list. Then we have the second number, third, fourth, fifth. The numbers wrap. 15.7 is the 6th number in the list, and so on. Which means that if you jump down into a long list of numbers and say 223, that is going to be the 72nd element, because the first number in the list is 71 and the second element is 72. So it gives you, it's a helpful way to get the index or the position within a list. Alright, so all we've done is used R as a calculator so far. Let's start assigning variables. This is where things get powerful. 1 to 5, okay, we know what that is. I'm going to highlight that and press enter, control enter to submit it. And this little left arrow, which is actually 2 characters, it's the left than sign, it's the less than sign, and then the hyphen. Those 2 symbols are a way to assign whatever is on the right hand side to a variable on the left hand side. So the variable A will now take a value. Notice when I made that assignment, it didn't print what the value is. It just put it into the variable A and went to the next line. Now I'm going to show you, let me do this, RMA. RM is to remove a variable, and I'm going to run that command again. Okay, I'm down here at the bottom left. I'm going to assign 1 to 5 to A. Press enter. In the environment, this tells you which variables are in memory. So currently we have assigned variable A, and the value, it is an integer list. It is 5 long, and the values are 1 to 5. 1, 2, 3, 4, 5. Okay? We're about to do that for B. B is going to go from 15 to 3, and is going to have a length of 5. So if you work that out, I hope those are nice numbers. I think they are. I think I'm counting down by 3s. B is 15, 12, 9, 6, and 3. And notice in the environment, I have those values. Alright, we're about to multiply. So A times B, what is that? That's going to be assigned to C. Now, I'm actually doing a bad thing here, and I'm going to change it right now. Recall what C is. C is a function. If you assign C to be a variable, now when you ask for C, R doesn't know whether you want the variable numbers you assign to it or you want it to perform like a function. So I'm going to change that to D, and I'm going to assign A times B equals D. And I just pressed a bunch of keys and it did a whole bunch of stuff. Alright, that will be fine. Let me just start at the very beginning of this thing. Okay, so I've assigned 1 through 5 to A. I've assigned 15 down to 3 to B. And when I multiply A times B, this is going to go element-wise. So that means for the first element in each vector, 1 times 15 equals 15. 2 times 12 is 24, and so on. The last element is 5 times 3 is 15. So D is the element-wise product of the list A and the list B. Now sometimes I'll use the words vector and list interchangeable. Both of them mean a string of numbers that have a position along a list or a vector. Alright, number 3, basic functions. So R has bunches of functions built in, and many of them are listed here. So recall what A is. A is the list of numbers 1 through 5. And I'm just going to plow through these. So the sum of A, that's going to add up all those numbers. 1 to 5 equals 15. The product of those numbers, okay, that's sort of, in this case it's like 5 factorial, gives us 120. the mean of those numbers. That's the arithmetic average. That's the number 3. What's the standard deviation of A? Okay, that's one I couldn't do in my head, 1.58. The variance is the square of that, 2.5. The minimum value, number 1. The median is the center point, 3. And the maximum is 5. And the range, I long expected the range to give the distance between the maximum minus the minimum, but in R it gives us the two extreme values, the minimum and the maximum. If you actually want the distance between them, you can wrap the output of range with the function diff to take the difference, and that's 4. Okay, I'm going to show you one more thing now. In the top right window, I've got a tab labeled History. I'm going to click on there, and History keeps track of all the commands that have been submitted to the console. So starting, say, at this A was assigned 1 to 5, B was assigned, and so on, and we took the product, D equals A times B. Okay, those are all the commands that we've submitted. Let me put in another command. I'll just ask for help on the function diff and press enter. All right, and I'm going to go back to history. Now I've got that diff there. And there are a few things that you can do here. Let me make a little space in my editor window up top. You can select rows here, and I'm going to click on one row. I'm going to hold Shift and press and click again, which is going to give me all the rows in between. And there's some options up here on the top. I can send these lines to the console, which is the bottom left window. I'm going to do that right now. Console. Okay. And it copied all those over there, and then leaving me to press enter if I want. And then I could also, I didn't press enter, and then I can also click to source, which means it will take these lines and put them up in the top left window. I'll click that right here, and now I've got those commands. So what that means is that if you're working down in the console, for example, working something out like I want A, okay, I want the range of A, okay, I actually want the distance from the min to the max, so that's the diff of the range of A, and you finally get the command you want. Yes, that's the command I want. There's a few ways you can move that into the program that you're working on up top, right? You can just select copy with a Control C, paste with a Control V, it up there, or you can go to the history on the right and move that to source. And maybe you like the sum. If you hold the Control key or the Command key on a Mac, you can do sum, say variance, the max, and the range, and just move those lines. Okay, that works just nicely. So you've got some. It's nice. It records what you're doing. So if you end up with a good idea and you want to find it, look in your history. All right. So the next section, let's go back to the notes and lock down where we are. We went through R as a calculator. I'm going to page down. We talked about vectors or lists. And I'm paging down. We've assigned variables, paging down. Some basic functions. So the functions that we looked at are either going to be included in the base package or in the stats package. There are a bunch of packages that are loaded by default into R, and then there will be additional packages that we install. And it's worth knowing where some of these functions live. So I'm going to, in the bottom left window in the console, I'm going to Control L to clear this, and I'm going to ask for help on the base. Okay, that's the base package, and I sort of appreciate R trying to help me out, but not always. Sometimes it just gets in my way. So here's the R base package, okay? And whenever you look at the help for a package, look down at the bottom at index. I'm going to click on index, and it's going to show me all the functions in that package. Now there's probably a few hundred functions in this package. For example, one that we've seen already is this letter C here to combine values. Okay, that's built into the base package. Let's also look for help on stats. And this is for the stats package. I'll click on the index at the bottom of the help window. And this also has at least 100 functions in it. And something that we've seen, if I scroll down to, how about the median? Okay, I'm going to click on median. And here's the usage for the function median. And we're going to see what some of these options do a little bit later. All right, so I'll go back to the notes and scroll down a bit more. And extracting subsets. Okay, so once you get a list or have a matrix or a data frame, these are different data types we'll be seeing through the semester, it's important to know how to get to the values that you want. All right, so I'm going to start by creating a list from 0 to 10 by 10 and assigning that to the variable A. So if I ask what A is, there it is. It's a list 11 elements long from 0 to 100. And these square brackets that follow A are going to include the indices for the elements that are going to be returned. If you leave it empty, that's the same as asking for all of them. A5 within square brackets. Notice square brackets, not round parentheses for these indices. This will give me the fifth element. So if I count 1, 2, 3, 4, 5, the fifth element is 40. So the fifth element is 40. Okay. You can combine and ask for a set of indices. So the second element is 10, the fourth element is 30, and so on. So I'll run this command, and I get just those 4 values. The minus sign out front of indices means to exclude those elements. And it's important to recognize here that R will only let you either specify indices that are to be included or specify indices to be excluded. You can't do both. Okay? So this is going to exclude the second, fourth, sixth, and eighth elements. So I'll run this command, and we have all the numbers except 10, 30, 50, 70, which were those elements that we excluded. All right. What does this line do? So A is being assigned 2 values. Okay, so there's the 2 numbers, 333 and 555, and those 2 elements are going to be assigned to which positions of A? The first and the second positions of A. So I'm going to run this command, and then we're going to inspect A. Okay, so the first and second elements of A have 333 and 555. Okay, so that is that section. My recommendation throughout all of this is to be running these commands on your computer as we go along. And if something makes you scratch your head, play a little bit more. Make some changes, experiment, really have sort of a conversation with R. You know, have a back and forth. Give it things to respond to. All right, so here's our Boolean section. So Boolean expressions are expressions whose answers are trues and falses. So let me clear my window down here, get a clean slate. I'm going to show us what A is. A has those first 2 strange values, 333 and 555, and then 20 up to 100. So if you wrap something in parentheses and you give it some expression some comparison expression like greater than, then it's going to return true and false for each element. So I'm asking, is for each element in A, which ones are greater than 50. So I run that, and so it asks, is 333 greater than 50? True. Is 555 greater than 50? True. How about 20? False. And so on. Even when you get to 50, 50 is not greater than 50. That's false. The next one is 60 is true, and so on. And this wrapped, and so the last one, true, is 100. All right. There is another function called which, and the function which gives you the indices that are true in a vector. So if I do Control Enter here, it's going to tell us elements 1 and 2 were true, and then elements 7 through 11 were true. Okay. Let's see, I'm not quite there yet. So you can nest all of these commands. So this command, we've already seen those parentheses, a greater than 50. I'm going to press Control Enter here, and that gives us those true and false values. Then, those are the indices, all the ones that indicate true, for which A is going to pull out that subset. So which elements of A do I want? The ones that are true. So I'm going to run this one command, and I'll get all those true commands, or all those true values. No buzz marketing. All right. Exclamation point, what does that do? It negates trues and falses. So what was true becomes false, and vice versa. So this is effectively asking which values of A are not greater than 50. And so notice I've got all my trues and falses flipped. Okay. And if I put that within the indices of my expression A, it will return all the ones that are not greater than 50. That's these four, which are now off the screen, but we remember what they were, 20 through 50. Okay, so there's lots of, well, at least there's at least 7 comparison operations. There's less than, greater than, less than or equal to, greater than or equal to, exclamation equal, that means not equal to. Double equal is asking whether it's equal to. If you use a single equal sign, R is going to treat that as a local assignment, like you want to save a value into a variable name. So you need the double equals. This is a common mistake to ask, is A equal to B? But you use a single equals, and when you ask is A equal to B, you actually assign the values from B into A. So be careful of that. And then %in% asks, well, we'll see an example of it in a second, which elements of the first set are in the second set. So it's a handy way of asking about set membership. So let's recall, let me clear my console down below and make a little bit more space down there. Recall what A is. It's got those two big numbers and then 20 up to 100. So we can ask which element of A is equal to 50. I'm going to run just that command first. And this is a really handy way to debug your code. Start from the inside of your parentheses and work out. So which values of A equals 50? I'm going to press Control Enter, and it is this one. This is the 6th element. And that is the number that I want to return from A. So that 6th element is the index that will be returned. That's number 50. That's a long roundabout way to get 50. Probably didn't need to do that. Okay, how about which values of A equals 55? False for everyone. We knew that. Now I'm going to ask to return that value from the vector A. Numeric 0. This means you have a list that has a data type of numeric, but its length is 0. So it's sort of like you have nothing. Okay, how about this one? Which values of A are not equal to 50? Well, that's all of them except for position that has the value number 50 in it. Okay, so if I return all those, I'm getting all of the numbers except for 50. All right. So this is pretty straightforward. Give me all the numbers where A is greater than 50. Give me all the values that are less than 50. And the last one, give me all the values that are where A is less than or equal to 50. Okay, so that's basically the same thing, except I also include 50 in my list. All right. Finally, the in function. So let me clear my console down below. Let's remind ourselves what A is. And we have this list here, 10, 15, 40, 60, 99, and we're going to ask which one of those, or which of those are in our vector A. So I'm going to press, let me just submit this one down there. I didn't need to, but just showing working from the inside to the outside. I'll run the whole thing now. All right. Is 10 in our list? Nope. So that is false. Is 14 in the list? False. Is 40 in the list? Yes, that's true. Is 60 in the list? Yes, that's true. Is 90 in the list? Nope, that is false. All right. Handy way to ask whether elements are in a larger set. And then you can start combining these things. So when you have Boolean expressions, you can ask and, or, and the exclamation point is not. So this is where things start to get more detailed. Control L. All right, so there's our vector A. So this command has 3 parts, actually 4 parts that we want to inspect. So the first one is, which elements of A are greater than or equal to 50? And if I submit this, I'll get a series of trues and falses where those are greater than or equal to 50. Okay, so 50 is this true one here. Then we have another list of trues and falses. Which values of A are less than or equal to 90? If we run that, those first 2 are not less than or equal to 90, but a bunch of them are all the way up to 90, and then the last one, 100, is false. Okay. Now this ampersand is going to ask the first one and the second one. They both have to be true for the result to be true. So I'm going to run all of that, which is going to, element-wise, say, is the first element true and false? True and false is false. They both need to be true for it to be true. The first one is here, where we have true and true is true. Okay. And finally, those are the elements that we want to return from A. So I'm going to run the whole expression now. And finally, we get the elements where A is greater than or equal to 50 and A is less than or equal to 90. So all the numbers from 50 up to 90 inclusive. The pipe, which is the shift / key above the enter key, is the Boolean operator OR. So the OR command, as long as at least one element is true, the result is true. So here we've got, let me clear the deck here. Control L is going to clear the deck. There's our vector A. So which values are less than 50? Just 3 numbers, 20 to 40. Which values of A are greater than 100? It's going to be those first 2. And that's it. And so this command asks which values are less than 50 or greater than 100. So element-wise, the first one is 333, so it was not less than 50, but it was greater than 100. So false or true is true. And so for these first 5, we had at least one true value in our initial vectors, and then the rest of them were false. So we've got falses. Okay, finally, if I run the whole command, I get all the values that are less than 50 or greater than 100. All right, and the rest of this works the same way. The exclamation point is going to negate the trues and falses, so we've seen that before. If I run just this command, let me clear the console. Which values of A are greater than 100? That's just these first two. And if I include the exclamation point now and run that, it will reverse all the trues and falses. So now those are the values that are not greater than 100. And so on. Okay. Missing values. So if you try to, say you were taking measurements, okay, and you were measuring your classmates' heights at your table, and 7 people were there and 1 person was missing, and you had a table of, so you had a list of 8 numbers, and you had 7 measurements for people's heights, and then the 8th person was missing, and so you recorded NA. NA is the symbol that means not available. And if we ask about what NA is, with a question mark, not available, that's a missing value. So what happens if you take a value, take a value whose number you don't know, and you add 8 to it? Well, that number is still not known. So basically, when you perform computations with missing values, you will get missing values, which will cause us trouble when we do analysis. So we often want to care a lot about whether which values are missing, and then make decisions about that. So what's 3 times a missing value? Also missing. What happens if you calculate the mean? So here's our list. 1, 2, and NA. The third element of our list is missing. Compute the mean of that. That means add them up and divide by 3. Well, when you try to add them up, you get a missing value. So, fortunately, many functions have a way to handle missing values. There's an argument here, na.rm. So effectively, for the NA values, do you want to remove them? RM. True. So if we take that same list, though I've reversed the order for some reason here, NA 1 and 2, let's just look at that below. Okay, we've got NA 1 and 2. The NARM first removes the missing values, so it removes NA from the list. So effectively we end up with the list 1 and 2, and then it computes the mean. So if we run that command, 1.5. All right. If we try to calculate the sum of this, that's right, missing value, until we remove the missing value first and get 3. Great. There are ways of removing missing values, of course. First of all, you can remove them manually. So let me clear the console and press Control Enter. That will submit this line here. By the way, think ahead. What is this going to produce? I've got an NA, comma, 1 through 5. That's the numbers 1, 2, 3, 4, 5, and then NA. So it should be a list, 7 elements long, with NAs on as bookends. All right, so I'm going to assign that to A. And we've got lots of functions to deal with NAs. There is a command is.na, and in fact there's tons of is functions. If I look at question mark is period, that comes up with lots of options. So we can ask whether things are NAs, okay, whether they're missing values. We can ask about data types. Is something an integer? Are numbers finite? Which elements are infinite in our list? For that matter, is this a list? Do we have any null values? Is this numeric information? Is this value a date? So you can ask about all sorts of data types. This turns out to be really handy. In particular, this isNA function I use all the time. So isNA is going to return trues and falses. So which values are NAs? The first one was an NA, the middle 5 were not, and the last value was an NA. Okay. And of course, if you put an exclamation in front of that, that will say which values are not missing, reversing all that. So we got trues for our non-missing values, which means that maybe you want to return only the values that are not missing. So first determine which ones are not missing, and then return those indices, just 1 through 5. Now I haven't rewritten A, so A still has those NAs. Okay, we can update our vector if we want. So what does this command do? It finds which values of A are missing, and then with the exclamation point it says not missing, and it returns those values. That's this list down here, 1 through 5. And then it assigns that smaller list to A destructively. So now A is 1 through 5, no missing values. That's probably what we wanted, but it is important to know that when you do a command like this, where you take A and assign it to A, you lose the old information. You can't go get those missing values back. All right. So that is the first part of this lecture. We have walked through all the stuff that looks like command line stuff, and I've got 3 questions for you, and I'm hoping that you'll do really well. So if you get these 3 questions, you are totally getting this stuff. And if you're struggling a bit, that's probably where I expect you to be. This is new to you, and it's hard to think like a computer. So I've got these 3 clicker questions. For each one, I recommend pausing the video, getting out a piece of paper and a pencil or pen, and acting like a computer, and writing down what you think the results of each command are, and arriving at the answer. So for example, I'll get you started. On this piece of paper, I'm going to do it right now. So we've got X takes the values 1 through 7. So I'm going to, on my piece of paper, I'm going to write X equals 3, 4, 5, 6, 7. It's that list. Okay. Next part. C, 1 and 2. And so that's a list 1 and 2. And then X bracket, what does that mean? That means I'm going to pull out element 1 and element 2 in my list. So this part of this expression, I'm going to write it down, is 3 and 4. I'm going to put them in parentheses and separate them by a comma. So it's left parenthesis 3, comma 4, close parenthesis. I'm walking through this a bunch with you. That's okay. The second part, elements 1 to 3, but there's a minus sign out front. So I'm going to take the values of X except the first through the third value. So the remaining values are the 4th and the 5th value. Which are those? If I look at my original list, I've got 6, comma 7 in parentheses. Okay. Now I'm going to add those 2 together with the plus sign. So when you add them together, that's element-wise. So the first element of each is going to be 3 and 6 is 9. And then the second element is 4 plus 7 is 11. All right. Doing good. Prod. Now you may not know what prod is. It's going to take the product of the elements in Y. So Y is the list. I'm going to write that Y equals the list 9, 7. Okay, so the product, I'm going to multiply all those numbers. 9 times 11, I know that, is going to be assigned to Z. So what value is Z? I hope you got it. So on the next slide, you can pause it here if you like. This is the worked solution interacting with R for each step. All right, 2 more. It's not a 2 more. So pause it here, and we'll come back and look at the answer. All right, you're back, or you never paused it at all. Here is the worked answer. So I take the sequence, -3 to 3 by 2, assign that to x. Here are the values, -3, -1, +1, +3. Then I ask which values of x are greater than 0, and return those values into A. Okay, of course that's going to be 1 and 3. Then I ask which values are less than 0, and assign that to B. That's going to be -3 and -1. When I take the difference of the first element of A, okay, so the first element of A is 1, and the second element of B, that's -1. I've taken 1 minus a -1, so it's 1 plus 1 equals 2. All right, if you're getting it, you're thinking like a computer. Last one. What value is Z? This is pretty tricky. Press pause. It might take you 3 or 4 minutes. That's just fine. All right, I'm going to pretend you're back. For all I know, you paused it forever, and I'm talking to myself. So, A is the sequence from 2 to -3, so we're counting backwards. 2, 1, 0, -1, -2, -3. In fact, I'm just going to go to the next slide and zoom on in to this. All right, so there's A. Which values of A are greater than 0? That's these first 2. So 2 and 1 are those values. And then which values of A are less than or equal to 0? That's these last 4. Okay. And then I asking the ampersand, okay, which ones of them are both, let's see, yeah, both greater than 0 and less than or equal to 0. Well, gosh, that should be nothing, right? Yeah, so B is an empty list. So B doesn't include anything. All right, let's keep going. The next expression, the one for D, asks which elements are not greater than 1. Okay, so that's 1 and smaller. Which ones are less than or equal to -1? So you start at -1 and you go smaller. Okay, so where are those true together? Well, let's see. It's got to be the -1, -2, -3 appear in both lists. So we're going to assign those elements to D, and in fact, we got that. -2, -3, oh, you know, these numbers. So now we're going to add together B, the list B, and the list D. Well, the list B was empty. There's no numbers there. And the list D are these 3 numbers. You add those up, you get -6. Hope you got that one. So, how'd you do? You know, if you're kicking butt on this, that's awesome. It probably means that you've been programming before, or that you worked really hard and you paused through this video and you interacted with R and you're really getting it. If you're getting some of the steps but are missing some details, you know, I think it's just going to take practice. So, and if you're sort of understanding the concepts, but you know some of the symbols are getting away from you and you're losing track of some of the details, and they're making your eyes spin, then don't worry. You've got support. You've got friends sitting next to you. You've got peer mentors. You've got me and TAs. We're all going to be there to help you out and be successful. So it's going to take work. You know, you're basically learning a new language, and you will get better with practice. And of course, working in teams is going to help a lot. So let's see, I got a footnote on practice, practice, practice. All right. Are you going to Carnegie Hall or what? All right, so the next part of this video, we are going to start talking about ggplot, the grammar of graphics, and plotting.